All right, so lesson 3. So this is like the second part of lesson 3. So I have proportional sides, or actually, let's do this. Let's call this similar triangles. Similar triangles. Now, two things are true about similar triangles. The first one we already mentioned, and I've already marked them right here. All the angles are equal to each other. So if you want to get real fancy, we say the corresponding angles, angles, that's the symbol for angles, are what? What's true about A and D, B and E, C and F? They're what? They're equal. Or in geometry, what's a word we use? Yeah, you could say equal. I'm fine with it if you say equal. Some geometry teachers love to say congruent, but I'm okay if you just say they're equal to each other. All right, now 2, the corresponding sides, I'll just shorten that up. Is that okay? CORR. The corresponding sides. Now, they're obviously not equal to each other, so we don't say they're equal. We don't say they're congruent. Daniel, what's the word you said? No, you said something else. Corresponding sides, right, are, yeah, we could say proportional, or I'm going to say in proportion. Okay? Oh, I was like, what's that D there for? Because that was the D for that triangle. I was like, okay. So the corresponding sides are in proportion. Skip over that D. All right, so are in proportion. Now, what does that mean? Let's set this up. So if I said AB, if I wanted to do a comparison, a proportion basically is a comparison between two things, all right? So I'm going to compare the sides. I'm going to compare AB to DE. Now, let's set up a little ratio right here, a little proportion. So AB to DE is equal to, what do you think? Yeah, let's go AC to what? DF, good, which is equal to BC to EF. All right? Does that make any sense at all? All right. Now, how in the world is that going to help us? Well, let's do this. I'm just going to pick real easy numbers here. All right? So let's just say that this is, I'll tell you what, let's pick the numbers down here. Let's say that's 3.
4, 5.
It's not 4, 5 because that would be a right triangle. That doesn't look like a right triangle, does it? So let's say this is about, I don't know, we'll just go weird numbers, 7, and let's say this is about 5. Is that all right? That's good enough. All right, so let's say that's 3, 5, and 7. What if I said that this was 9, let's say. All right? So I've got 5, 7, 3 over here, and this side is 9. I've got a lot of writing over there. Let's change colors. Let's make this red. And so what if I called BC X and I called AC Y? And that's what I asked you to solve for. All right? We're going to use this proportion right here to solve for X and Y if I know some of my sides. Now look, what corresponding sides do I actually know? I know 9, and what side corresponds to that? The 3. So what I'm going to do is I'm going to set up a thing called a scale factor. And the scale factor is I look at the corresponding sides, and in order to get the scale factor, I need to know both of those sides. Okay, so I need to pick. Now look, if I said 5, look at the corresponding side to 5. I don't know what it is, do I? So I can't use that as a scale factor. What about 7? I don't know what the other corresponding side is, so I can't use that. So I have to know both of the corresponding sides in order to find the scale factor. So I know 3. What's the corresponding side? That would be the 9. Do you see that? So I know they go together. Now, you could take this triangle and kind of twist it around and flip it and stuff like that, right? Because right now it's set up nice and easy for you. It's just perfect to see which ones correspond. But what if this was flipped around and you couldn't really tell which ones matched up with what? You could always see what angle that side is opposite. That's what I'm going to, and we're going to see that in a few minutes here. So look at side, this 3. It's opposite the angle with 3 arcs to it. So you come over here and you say, well, how do I know which one corresponds to this one? Well, you look at the angle with the 3 arcs, and it's across from that, right? So it's across from the same angle, basically, from equal angles. Does that make sense? So you'll see how that really helps you out in a little bit. Right now, it's real easy to see which ones match up. So anyway, I'm going to do a scale factor of what? 9 to 3. I could go 3 to 9 if I wanted to. It just depends on which one I want to compare first, right? I'm going to go from the bigger one to the smaller one, left to right. You okay with that? And if I reduce 9 to 3, of course, what is that? 3 to 1. So what I'm going to do is I like to figure out what my scale factor is first. And then I can set that scale factor to the ratio of the other corresponding sides. So watch, my scale factor is 3 to 1 equals, now let's solve for y. So I'm going from big side to little side, right? I'm going from big triangle to little triangle. So yeah, I'm going to go y over 5. Does that make sense? And then cross multiply. In this case, it's a little easier than that because that's just a 1, right? So really all I got to do is multiply both sides by 5, or you could cross multiply if you wanted to. Y equals 15. So that's what that side is right there. Y is 15. Do the same thing with the x. I made this really, really easy for you because basically what? That side is how much more than this? It's 3 times the smaller one, right? The bigger side on this triangle is 3 times bigger than the small triangle. Make sense? So I could have just looked at this, said 5, and what's that? 5 times 3, right? It's 15. I looked at this as 7, so what's this side going to be? 21. They're not always going to be that easy. I started off the first one really, really simple. But let's just go through the method again. So I'm going to solve for x this time. I'm going to write my scale factor, and then I'm going to go x to what? 7. It's an x over 7. Cross multiply, so x equals 21. Now that was really easy because you could just see that this side was 3 times as big as this side, and that's all you have to do with the other ones, right? Just multiply this by 3 and multiply that by 3. Are we good with that? But I want you to see how to set this up because in this next example, I think it's important that you see how to do the scale factor and all that kind of thing.
Will we get one where it will be like that, where we easily tell?
Yeah, sure, you could.
After you solve one of them, could we easily tell the other?
Yeah. Well, what do you mean after you solve? Like
Will
once
they
you
give us
solve
one-
for
will
y,
they
you
give
mean?
us- If you solve for x or y, and then they give us like a triangle like that again, will it be easy to figure out the other one without going on with that?
Not really exactly sure what you're saying. Oh, excuse me. I'm not sure exactly what you're asking, but like I made this one easy because this is exactly 3 times as big as this. Sometimes it's like the scale factor might be like 7 to 3 or something. You know, it's not exactly twice as big. It's not exactly 3 times as big.
That one, and you get one of the answers. Can you easily figure out the other answer without doing the math?
I would say easily no. I would do the math. Okay, yeah. I would say for the most of the ones you're going to get, most of them, I'm not sure. I don't have every single problem memorized, but I would say for most of them, you would want to find your scale factor, set up your little ratio, and then go ahead and do it that way. It doesn't take that long. I mean, that wasn't that hard, was it?
No.
Okay. So I would say we always do it this way. Is that all right? All right. Let's pause this, and we'll do one of the examples from the book. All right, so what I've done, I've drawn a situation here where I have 2 triangles, and they are similar triangles. This was given. All right, we already figured out these 2 were equal to each other because they're vertical angles. And if I have 2 angles of one triangle equaling 2 angles of another triangle, the third angles have to be equal as well. That's actually a theorem in geometry that we discuss, but you can figure that out pretty easy because you just take 2 equal angles away from 180, and you're going to get the same thing on both of these. All right, so now what do we have? What kind of triangles are these? Similar triangles. Okay, so they are similar triangles. That's supposed to be a triangle. That's a little ugly. So that's similar triangles. Now let's put some numbers in here and see if we can solve for something. 4, 5, we'll call that one x. We'll call this 6, we'll call this 7, and we'll call this side y. Are you with me?
Can you again set up ratios?
Yeah, that's what we're going to do. Okay, that's what we want to do. First of all, we want to find what? We want to find the ones that correspond to each other. What do we call that? 2 words. Look in your notes. You should have written it down. 2 words. When you get the corresponding sides and you know both of the sides. It's 2 words. We call it a blank blank.
Scale factor.
Scale factor. Very good. Okay, we call it the scale factor. Let's look for the scale factor first. Okay, look over here. I got 2 sides over here. I got 2 sides over here. But which ones correspond to each other? This one's not quite as easy to see as what we had earlier, is it? The other one earlier was set up perfect. You know, I mean, you looked at the one on the left and the one on the left, you know, was the same. But on this one's not quite so easy.
This one for y?
Well, let's find the scale factor first. Let's not set it up. Let's just find the scale factor.
Oh.
So let's look at this 4. What side over here This is a small triangle. This is a big triangle. This side is 4. Look what side it's or look what angle it's opposite. It's opposite the angle with 2 arcs, right? So what side over here corresponds to 4? The y does. Okay. What about the x? X is opposite the 1 arc. So what? 6. So x to 6. So what do you think is left? 5 to 7. Look, 5 is opposite the one with 3 arcs. And guess what? 7 is opposite the one with 3 arcs. So what's our scale factor now with these two triangles? 5 to 7, right? Okay, 5 to 7. If you want to go small triangle to big triangle or left to right, you know, that's good. You could have gone 7 to 5, right? But I'm just going to go 5 to 7. All right, so our scale factor is 5 to 7. That means for every 5 this one goes 7. So remember the other one, when it was real easy, went 9 to 3 or 3 to 1. This one's not quite as nice of a scale factor, is it? Right? So you can't say this is, oh, this is twice as big as this, or 3 times as big. It's not. It's 5 to 7. It's just a little bit harder to see. So we set it up. Now what do you want to solve for first? Let's do x first, okay? So how are we going to set up our ratio for x? X to what?
6.
X to 6. That's right. Because again, x is opposite the 1 arc here. 6 is opposite the 1 arc, so it's x to 6. And there's our proportion. And now we can just solve for it. And we cross multiply. Or you could just multiply both sides by 6. Couldn't you? You could cross multiply, but since x is already on the top, watch. Just multiply this by 6. That cancels out. Multiply this by 6. So what do we get? X is 30 over 7. And just keep it like that. Just keep it 30 over 7. You don't have to change it to a decimal. Don't change it to a mixed number. Just keep it like that. There's no reason. I mean, look, I know that you and anybody else could throw this into a calculator and get a decimal number. All right, I'm done. Right there. That's your answer. 30 over 7. I know when you're a kid, your elementary teachers, your middle school teachers, even your probably Algebra 1 teachers, forced you to take an improper fraction and make them to a mixed number, didn't they? All right, do you remember that? Yeah. In fact, some teachers even say, well, that's reducing. Well, it's not reducing the fraction, changing that to a mixed number. All it's doing is just changing the form of it. I'm fine with you leaving it 30 over 7. We okay with that? All right, let's do y. Now, we keep that same scale factor. What was our scale factor? 5 over 7. So keep the same scale factor and set it equal to the proportion on the other side. So we're going to do y this time, right? Now I'm not going to put y over, because if I'm going from the small one to the big one, what am I going to have to do? 4 to y. That's right. So I have to go 4 to y. Oops, I put 7. It's a y. All right? Make sense? Now in this one, I'm definitely going to cross multiply. So we cross multiply. So I get 5y equals what? 28. Divide both sides by 5. And there's my answer right there. Y equals 28 divided by 5. And you can keep it just like that. Now, if you wanted to change it to a mixed number or to a decimal, you could. I'm not making you, though. All right, if you wanted to, that would be all right. But I would just leave it like this. And I'm looking in the book, and that's exactly how they leave their answer. They leave their answer just like this. All right, saves you time, right? Saves you that possibility of making a mistake, right? Changing it to a mixed number. So I would just keep it like that and be safe with it. Let's do one more example. Yeah. All right, let's go through this real quick. Let's take a look. We want to solve. We want to find a scale factor here. Well, you know the right triangles, right? You know the right angles. You know the vertical angles, right? So which one? Look, this is a 7. Which one matches up with the 7 over here? The 10, because it's opposite the right angle. 10's opposite the right angle. So my scale factor is 7 to 10. I only have a minute, so let's go a little quick here. Let's solve for x. Well, look at x. X is opposite the vertical, but is 8 go with the x? Look, x is opposite this 1 arc. Look, z is opposite this 1 arc. Can I put x and z? No, I can't. I got to do the y, can't I? So y is opposite the one with no arc on it. So which one's opposite the one with no arc here? The 8. So I have to go y to 8. Everybody see that? Now I can cross multiply, or just since it's on top, just multiply it by 8. And then it's 56 over 10. You can reduce it. Actually, on this problem, they actually do write it as a decimal. So that's fine. You can keep it as a decimal. So y is equal to 5.6. Let's go to the next YouTube video, and we might have time to finish this up.